The Marshall JCM800. It's the greatest amp Marshall ever made, along with the Plexi, and of course there's the JTM45. But the 800 just has that The tone is hard to define. It's like eating a Marmite cheese and chip sandwich. You don't know why it's good, it just is. Wouldn't it be cool though if there was a lower powered version? Maybe 20 watts, 6v6 tubes. Sure, there's a Studio Classic, but what if you could make your own the way you wanted to make it? Well, now you can. Click the link in the description and it'll take you right to the free plans of the PUNCHPLATE, a 20 watt JCM800 amp. You can run the PUNCHPLATE with 6v6 GTs, or with a larger transformer you can swap the 6v6s for 6L6s, or even KT66s. Before we get on to the build, let's take a look at the schematic and the two most well-known versions that Marshall created. The 81 schematic, the vertical input model, fed around 300 to 320 volts into the phase inverter, then onto the preamp. The lower voltage contributing to the sublime harmonic distortion and the particularly luscious asymmetrical clipping. The 86 schematic, the horizontal input version, was a little bit different. It fed an increased voltage of about 370 volts into the phase inverter. This provided the amp with a bit more aggressive stiffness and headroom. If we take a look at the PUNCHPLATE schematic, you'll see that the preamp is unchanged. The only tweaks include a channel switch and a slightly modified B+ filtering. In addition, the layout of the front panel has been altered to optimize the chassis layout. You can easily choose which flavor you prefer to build by adjusting R33. That's this little resistor located here. 15K gets you 81 tone, and 6K8 increases your headroom into 86 territory. I shot this particular footage about 18 months ago, and the plans have been honed since, and changed, and then changed again and honed some more, and then I made some mistakes, so I had to change things again. Now I've finally got the plans to where I want them, and you can print them out on A4 paper at 100% scale. Use the dashed lines to align the sides and turret board. I prefer to build an MDF template with which to cut out the chassis holes, but you can use whatever method suits you. A drill press is handy, but certainly not essential. Look out for this trap. Always check the component footprint against the plans. The mounting holes for these same but different transformers are different. The holes are out just enough to turn your day into a stink one. I was very lucky I caught this early. I use my trusty little router. And yes, I'm using a template to cut out my template. If I'm able to produce an accurate MDF template, it's far less likely that I'll screw things up. Famous last words. Note that my paper plans go to the inside of my template box. I made a plug out of MDF, which provides a solid backing when drilling holes. It prevents the chassis from suffering any pressure deformation. I used a scrap piece of wood so that I could mount the whole thing in my vise. The chassis goes into the box, and the plug goes into the chassis, and then the brain goes into the meat grinder. I use a router for the larger holes, 1/2 inch and up, and a drill for the smaller stuff, 10mm and down, and it works pretty good. For the turret board, I make my own flatwork, but you can buy it easy enough. It doesn't matter how much protective gear you wear, you're always itchy after sanding glass fiber. It's like hiking in the woods. No matter what happens, you always end up with a piece of dry fern or twig in your undies. It's the stuff of X-Files. Take your time drilling. It's super easy to wander off target. The standoffs are tricky. You need the turret board to match the chassis. Only drill one hole at this stage. Just one. One standoff hole. Use this as a guide pin to drill the remaining 3 holes. I use the chassis itself here as my template. In this way, it's a certainty that the turret board mounting holes will match the chassis. When you remove the turret board and check alignment against the plans, you will be glad you used this approach. It doesn't matter how careful you are, if you wing it, there will always be a discrepancy. Inserting the turrets in swaging is particularly satisfying indeed. I'm using an old Stanley countersink bit as my swaging swage tool. The price of standoffs is getting a little bit crazy as well, and you can easily use 2 nuts here. The width of each nut is 1/8 inch. This conveniently provides the exact 1/4 inch spacer desired. And similarly, you can use 4 nuts in place of a 1/2 inch standoff. These belt and sockets are nice, but the hole is not quite 4mm, and I like to use 4mm bolts here, so I carefully file out a little material. The beauty of having a template is that it's all ready to go for you to start on the filament cables. The gauge of the filament cable depends upon the size of the power transformer you are using. Look closely at the green cables of the transformer as a guide. The 372FX uses 18 AWG and the DX uses 20 AWG. I'm using the DX transformer for this build, so I'm going to use 0.8mm diameter solid core cable, which is about the same as 20 AWG. If you're using the larger FX transformer, use 18 AWG, or minimum 1mm diameter. I like to use solid core wire for my filament cables. I add my own polyolefin heat shrink for insulation. It's self-healing with applied heat and it stays put. I give these a pretty decent twist in the drill. I stop halfway to attend to any bunched undies insulation by applying some more heat, and then I give it some more twisting. My OCD goes into overdrive here as I like to get everything lined up, and this little guy really helped me out. This section can really try your patience, but you want to get it right. It's important, but it's tricky. So just take it slow, relax, and you'll make it through. Don't forget these little D connectors for pins 4 and 5. You can do it this way, or you can pre-bend and cut. This little guy just hung around, looking over my shoulder, checking everything. It was a good omen. You might have seen me using this tool and thought, "Chair, what even is that, bro?" I actually do not know. It was included in a box of vintage tools I bought online, and I can find no information about it at all, nor about the company that made it. If you know anything, leave a comment, for it is without doubt the most handy tool that I have. I like to use fairly chunky gauge cables for the filter cap return circuit, 1.2mm or about 16 AWG. This cable connects the electrolytic filter capacitor nodes to ground. In my original design, I route this cable underneath the board. However, for access reasons, I don't like having any cable running under the board. Also, I dislike the idea of having to drill large holes in the turret board. Hence, the new plans have neither holes nor underboard routing. Makes things simpler. I simplified this region as well. No need for unnecessary right angles. Board access can get tight, hence order of component installation must be carefully thought through. To avoid accidentally touching components and melting something, I start in this area. It pays to check the accuracy of each component as installation progresses. Some turrets, such as this one, are particularly busy, and it's advantageous to solder when you have ample room. Double check that you have included every component and hookup cable. Inspect the turret, ensuring every component has sufficient solder with no dry joints. Note that this turret accepts the 50-volt bias tap. Hence, the top half of the turret will be easier access for the bias cable, more so than the lower half. Try not to stress the component lead connection. The turret acts as a lever, and if you're not careful, you can rip the lead right off the component. Always make sure there is a little bit of slack between your component lead and the turret. Originally I used 470k resistors here, however it's best to use 220k 2-watters. Plans have been amended. You can use either 450 volt or 350 volt 100 UF caps here. I recommend the 450 volt caps, however, if you plan to use the larger FX power transformer. Don't forget to solder the turrets together. Adding a 20mm by 2mm machine bolt down the center is essential for alignment. Use of the blue Smurf Poop sticky clay is recommended as component support. Ensure that capacitor C14 sits above and is clear of the lead of the 1K 5W resistor R26. The bias pot lugs can be carefully bent upwards. The pot will then sit perfectly atop of the turrets. At this stage, I like to address the NFB feedback cable, as well as the ground cable seen here in red. I should have used blue heat shrink here, I know, to be less confusing. However, give yourself heaps, that is a lot of length, way more than you think. Bend it into place and it can be affixed later. Use your favorite shield cable here. I like to use Mogami if I'm not using my own. V3 is very busy indeed, so just take your time, get everything lined up, use heaps of sticky Smurf poop, get it all sorted, and things will all work out. The elevated high tension line, for safety reasons, is best insulated. I stuffed up here, soldered the 470k resistor to the wrong place. I only caught it later on. Dope. Despite a couple of minor errors, not looking too shabby. There are a heap of cables coming out of the power transformer, and it's best to deal with them in the neatest possible way. First, get rid of the uninsulated ends, as they scratch everything. I'm using 16mm grommets and they can get full. The grommets are perhaps best placed on the chassis first, then feed through the cables. The approach that I'm using is okay, but more problematic. It's up to you how highly you value the outward appearance of the chassis. I don't tend to worry about it too much, as scratches are inevitable, but precautions can be taken if so desired. I had to really test the tender join area between my thumbnail and finger to massage the grommet in, but in it went in the end. You can also use nylon washers here. I use kip nuts and I add some Loctite. You don't want these coming loose. Trim all unused cables to about 2 inches. For any builders outside of the US, yeah, you 240 volt guys, the brown and black cables need to be joined. You can either join them under the board, as shown here, or join them on the dedicated turret post. If joining under the board, insulate more than sufficiently. I bundle the unused cables and position so that they sit neatly along the base of the transformer. I noticed that the base of the output transformer was impeded by the rubber grommet, an unforeseen error. This was causing the chassis to deform. I have amended the plans to ensure that this no longer occurs. I add the remaining double turrets to the board, and now it's time to lift it from the template. I ran all the transformer cables to their final destination, leaving appropriate slack, and mark where they will terminate. After this, I remove the turret board from the chassis, as it's much easier to strip the transformer cables with nothing in the way. Now's a good time to attach a termination ring to the PT secondary winding center taps. These go to ground near the IC main socket. Let's revisit the on-off switch cables. I've used spare yellow cable as it's easier to see how they are twisted and terminated both at the switch and on the board. The blue primary cable and the yellow switch cable are then routed to the IC mains input socket. I originally routed and terminated the cables in this fashion, however it looked complicated and messy. This example is far better. The IC ground cable in this case is yellow. Use a shoulder washer here. The speaker output jack is insulated from the chassis. Also, use a fiber washer to the outside of the chassis. As mentioned previously, I should have used blue for the speaker ground cable. Here is a better example. Solder in both the switch common and feedback cables. Attach the 50-volt bias cable, and all looking fairly smooth, onwards and upwards. I forgot about the ground connections here. Continually check everything, for it's easy to overlook things. These mini 3-pole double throw switches are ideal for channel selection. I prefer the 1/2 inch bushing, however the switch with the 1/4 inch bushing is considerably cheaper. It's easier to prepare the switch outside of the chassis. The gain pot is located near the switch, perfect distance to position the resistor and bypass cap. Install shielded cable. This is where problems often occur. Check continuity of each cable, ensuring signal is not leaking to ground. I use Smurf poop to catch the lead offcuts. The last thing you want is any junk falling into the pots. Correcting my earlier careless mistake. Depending upon the size of your capacitors, this geometry may be possible. Looking neat and tidy, and I think that's a wrap. Test everything. Match each component to the schematic. Go through the whole circuit. Before turning anything on, I like to insulate myself from the potentially lethal parts of the amplifier. For this I like to use silicon tape or Tommy tape brand, and it's excellent at sticking to itself. Make sure you insulate the lugs of the on-off switch. It stops you from doing stupid things with your thumb, like this. And of course, don't forget the fuse. Perhaps the easiest way to set the bias voltage of the output tubes is to put your multimeter across the bias pot, and you want it to measure anything from 19 to 20k ohms. And that'll be around about minus 19 volts DC, which is about right for 6v6 tubes. Let's give this a go. I've got everything turned to zero. The moment of truth. Oh, I heard something. Oh no. What the heck is that? Right. Ooh. It's in the feedback circuit there. Some high frequency oscillation, something's going on. Well, that's not a good start. Alright. Ooh. Pop fizz. Oh man. Alright, let's plug something in. Can it get worse? And no. It's doomed. Yeah, it's not good. Instability. Oh well. Let's put it out of its misery. And a massive pop fizz to finish, why not? Right, let's give this another go. Master volume. I'm scared. It's not bad. There's no screaming. Whoa, full power. Whoa. Go. Wow, okay. So that was it. Good old output transformer. Primary cables reversed. Let's add some guitar. Ooh. It's actually pretty good, quite quiet. That's good, that's good. Just chuck in an FX loop, mate. I mean, how hard could it possibly be? Turns out, a little bit very hard. So difficult, in fact, I nearly walked away from the project. But quitting's not part of my deal. I quickly realized that it seemed that for every guitarist out there, there was a different FX loop design. And of the ones I tried, none worked particularly well at all. The send signal was just way too huge. A massive impedance mismatch was inherent in all cases. I tried what seemed like a solid LND 150 design off the interweb guru forums, and all it did was hiss and go. Then I tried the Marshall op-amp circuit, the one from the 59 reissue, and that was just about as bad. Can it really be this hard? Well, yes it can, and it looks like I'll be roaming as a pack of one, all by myself, alone, in the solid-state jungle wilderness. I'm well aware that there already exists a successful LND 150 zero-loss design. However, I'm a fan of op-amps, and I don't see any reason why they cannot be successful at driving a loop. Despite the Marshall 1959 reissue loop design not performing at all well, I like the power supply, and that might be a good starting point. In addition, the giant elephant in the room in my eyes is the series approach. I've gone to all this effort into building a decent preamp, and it defies logic to then want to ram the whole preamp output signal into the loop. It then has to degrade the send signal down to pickup level before magically reconfiguring the return signal back to the exact massive volume and geometry as the original tube amp dry tone. That's a monstrous burden for a poor FX loop to bear. A parallel type loop makes way more sense to me, as only a small portion of our beautiful punch plate analog signal need be split from the mother load, sent out to the loop, then mixed back in, with the bonus of retaining the majority of my dry tone. So the parallel loop approach was looking promising. And this worked pretty well. As soon as I split off a little bit of signal and sent that to the FX loop, it started behaving itself. I was actually getting somewhere. Unfortunately, it ain't that straightforward. For a guitarist's worst nightmare begins to make its presence felt, no pun intended. That four-letter word, phase. And yeah, I spelt it with an F. And a Z, okay. First, I had to ensure that the small signal that was split off the preamp returned to the power amp in phase, and that was challenging to say the least. Adding pedals began to mount my brain as I was getting these major phase problems and I didn't have a clue what was causing them. You can clearly hear a volume drop and also a high frequency roll-off. Although the blend knob did help things, it was not optimal. The FX loop must ideally be transparent and have the ability to achieve volume parity. I just assumed that I had a persistent phase issue with my design. So I continued with my blunt force tinkering and I came up with a couple of very nice prototypes. And they worked quite well, but I was still getting this high frequency loss and volume drop. And I was getting a little bit disappointed again. And then the penny dropped one night when I was wide awake asleep, and of course one of my pedals and also one of my mate's pedals was inverting the phase at its output, and that was stuffing everything up. It's just so stupid and simple. How could I not have thought of that? What kind of an idiot am I? It wasn't my loop after all. Yay! But I still had to fix the phase inversion issue. It was straightforward from there. An additional op-amp was required to invert phase, and it had to be switchable. So here it is, the final FX board, at last. The loop splits off a small amount of signal and sends it to the pedals via a buffer and a level pot. The level pot, by and large, is a set and forget affair, however it can be tweaked if you need a little bit more or less. The pot is a 24-turn precision burns unit, and to adjust, first you'll need to dial it back counterclockwise to 0, where you'll hear a faint click, then go from there. I initially set all level pots to halfway. The signal comes back through the return jack and is amplified. Overall signal volume, or level, is controlled by the FX Master volume pot. Pull to bypass FX mode, push to engage. The FX gain pot controls the gain of the FX signal. Push or pull the pot to invert the phase. This can be very handy, as many pedals invert their signal at their output. Conversely, sometimes pleasing tones can be achieved with an out-of-phase signal. Before installing the loop, you'll need a chassis that can accept the board, inside of which you'll need to build a punch plate amp and ensure that it works. Before installing the board, don't forget to thread both the red and black cables through their nearby holes. To easily install, first remove fixing hardware from both pots and jacks. Slide the FX loop module into the dedicated chassis holes. Apply fixing hardware to secure. Both the V+ and ground cables can be either wrapped around their assigned turrets, or more easily simply poked down the middle of the turret and soldered. The blue signal cable goes to the input of the MV pot, and the red signal cable goes to the MV wiper. Installation is complete.